A very warm welcome to Explore Science. This is Nikita to ease your learning. In this video, we will study Sir Isaac Newton's three laws of motion. So let's get started. First law of motion. Here we will consider three situations. First, when a body is at rest, it remains at rest until and unless an external force is applied on it. Second, when an object is moving at a constant speed, it requires some external force to move faster. Third, when an object is moving with a constant speed, it requires some force to get stopped. So in this, we will study that what is inertia. Inertia is a property of matter by which it continues in its existing state of rest or uniform motion in a straight line unless that state is changed by an external force. Newton's first law states that if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at constant speed unless it is acted upon by a force. This postulate is also known as the law of inertia, means that it resists the change. It means that some external force is required to bring that change. Now example of this first law of motion. Object at rest remain at rest unless acted upon by an unbalanced force. So let us see what happens when this ball is kicked. It will move. So it will move. It means that this kicking is by kicking this ball we are applying some force. Now next figure. An object in motion will continue in constant speed and direction unless acted upon by an unbalanced force. Now what is happening here? That the ball is stopped by an external force in the last diagram. So coming to the second law of motion, it tells that the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. So what does it state? Newton's second law is a quantitative description of the changes that a force can produce on the motion of a body. It states that the rate of change of momentum of a body is equal in both magnitude and direction to the force imposed on it. Means that if we are applying more force, more will be the momentum. The momentum of body is equal to the product of its mass and its velocity. Momentum, like velocity, is a vector quantity having both magnitude and direction. A force applied to a body can change the magnitude of the momentum or its direction or both. So let's see its example. Now here we see a man is pulling this wagon. To get the wagon to accelerate, one have to apply a pulling force. Without the pulling force, we can't move or we can't accelerate that wagon, right? So a pulling force is applied to make it move. Similarly, in the diagram below, the second one, their mass is more. When the mass is more pulling force is required. Greater the mass, greater the pull necessary to accelerate it. Fine. Now we will see the equations that are based on the second law. First of all, we come to this formula for momentum. Momentum is denoted by small p, which is equal to mass of an object multiplied by the velocity with which that object is moving. Now second law can be abbreviated as F is equal to ma. Now let us see that how this is derived. So these are the expressions. that F is equal to dP by dt, which is equal to, now here P is again broken down from the first equation. We have replaced P with mv. Now we know that v by t, that is velocity by time, is equal to acceleration. So directly we can write F is equal to ma. Now let us see the third law of motion. It is also known as action-reaction law. We have often heard that to every action there is an equal and opposite reaction. So let us see what it states. It states that when two bodies interact, they apply forces to one another that are equal in magnitude and opposite in direction. Now this is very much important here, that the magnitude is same but the direction is opposite. The third law is also known as the law of action and reaction. This law is important in analyzing the problems of static equilibrium where all forces are balanced, but it also applies to bodies in uniform or accelerated motion. Now we will see the example for this. In the first figure, we see the man is rowing this boat. So this rower, the boat rower, is applying force with the help of that oars, right? And as much force he is applying to get through the water, the same force is applied by the water to push that boat forward. He is applying force in the backward direction, and in turn the same magnitude force is applied by the water that the boat moves in forward direction. So in the second figure we see this book. We see that the book is placed on the table. The book is exerting some force downwards on the table, and in reaction the table is exerting same force, means same in magnitude but in upward direction. So the upward and the downward forces balance each other. They are in opposite direction. That is why the book is in rest and it is resting on the table. So this is the equation for Newton's third law. Here we see that suppose we have two objects as 1 and 2. We see that the force exerted by first object on the second object is equal to the negative of force exerted by second object on the first object. This negative sign indicates that though the magnitude is same, but the direction of force is opposite. So this was the brief about Newton's 3 laws of motion. If you have any queries, you can post it in the comment box. So if the video was helpful, you can like this video and make sure you subscribe this channel so that you are the first one to receive any video that is uploaded. Thank you.